You will need a calculator potentially, unless you're really good at mental math. So if you want to pull out your calculator.
I think it's 21.
Oh yeah, I got
Alright, everybody listen. Once we get into Unit 2, that's the only unit where we don't use calculators. Every other unit we have calculators. So if you do not have your calculator with you, make sure you start bringing it to class. Remember, you just need a scientific one. You don't need the fancy, expensive one. Just get a scientific. But if you need to borrow one, please grab it as you're coming in. I don't want to have to walk around and pass them out. Right? So if you know that you didn't bring your calculator on accident, go ahead and grab them when you walk into class. Okay? So today we're going to be learning about the segment addition postulate and the angle addition postulate. And you do need to remember those names. You guys are honors and we're going to be doing proofs. You will need to state different postulates and theorems when you use them, so you need to remember the names. So this one we're going to be learning about on this page is called the segment addition postulate, which we're allowed to abbreviate as is truly mathematician, the mathematician way is to abbreviate. You can call it the SAP if you would like. Basically what it says, it's common sense. You've done this before, we use it in a lot of different ways. So basically what it says is if you have a line and there's a bunch of points on that line, so they're collinear, you don't have to have 3, you can have more than that. But if it's broken up into pieces, if you add each of the little sections together, you get how long the entire thing is. Right? So for example, I have A, B, and C. If I know that AB is 13, and I know that BC is 8, how long is the entire thing, AC? 21, right? If you're just trying to figure out how long something is, that's supposed to be 21, you just add them together. Okay? So that's basically what we're working with here. And what I want you guys to write, and I'm not going to do it because I'm afraid I messed up my board, but in the margin up here, I want you to write part plus part equals whole. The words. Part plus part equals whole. Like whole thing. W-H-O-L-E. Part plus part equals whole. That's basically the concept here. Part plus part equals whole, or part plus part plus part, however many parts you have. If you add them all together, you get the whole. Above that, I also want you to write whole minus part. Whole minus part equals part. I'm going to try to write this, hopefully it doesn't mess up. These are 2 things I want you to have written up here. Excuse me, handwriting. It's like whale, but it's full. So whole minus part equals part and part plus part equals whole. These are the 2 kinds of ideas we're going to be using as we're working through these examples. You could use either one depending on what information is provided. Okay, before I move on, no board, I didn't want you to move. Before we move on, do you guys remember what this means? What are congruent? Congruent segments or congruent parts. So I want you to write congruent segments. That may be significant. You may need to add the congruent symbols or look out for them in a diagram. Do you guys know how to do the same thing for an angle? If I have an angle and I wanted to say that the parts of the angle were congruent, do you know how to do that? Not a line. It's a little arc. Right? That means congruent angle. Congruent angles. Right? Sometimes they won't tell you that they're congruent in the directions. They may have it in the picture, not the directions. So sometimes you have to get the information that you need about the picture from the directions. Make sure you're on the lookout for those. All right, we're going to go through these examples relatively quickly. All right, some of them are pretty straightforward. You guys slow me down if I'm going too fast, but I'm going to go a little bit quick through these because I feel like they're pretty straightforward. So when I give you guys information in a picture, I expect you to put the information into the picture and write an equation. All right, so I know that df, which is the entire length, I know that this is 18, and I know that DE is 5. How would I find EF? I would subtract. If I know the whole thing is 18, and I know one part is 5, if I want to know the rest of it, I subtract what I know away, and I get what's left. So that's, when I had you guys right at the top where I said whole minus part equals part, that's this. If you have the full length and just a little snippet of it, if you subtract what you know away, you can get what you don't know. Does that make sense? Okay, this next one, I know that DG, which is the full length, that is 19. I know that EF is 10, and I know that EG is 16. What I'm looking for is this. In order to find that part that I kind of scribbled, what do I need to know before I can find DF? No, I don't need to know FG. In order to find DF. What part of DF do I know? I know E to F. What don't I know? D to E. So my first job is to find DE, so I can add those together to get the full DF. All right. So how am I supposed to find DE? Okay, so DG minus EG, which would be 19 minus 16. So everybody see how I did that? I have the whole length, and then I have this gobbledygook that I don't really want. So I subtract it away. That's how I get DE. What's the measure of DE? 3. So now do I have everything that I need to find DF? Yes, I do. If I take DE, oops. If I take, well, okay. If I, hold on, one second. Stop being obnoxious. If I have DE and I add that to EF, that will give me all of DF. So I have 3 plus 10 equals 13. That's what I'm after. So sometimes they're really straightforward. They give you everything you need, like in this first example. Sometimes they give you everything except one little piece. You need to find that first before you can find the final answer. Right? Sometimes you have to take a back door to get to where you need to go. First, you okay? All right, make sure you're going to stop me if you don't understand something. What does this symbol mean? What do you guys think? It means congruent. Very good. So they're giving this to me in words. I want to represent that on the diagram. How would I do so? How do I illustrate that they're congruent on the picture? The little hash marks. DE is congruent to FG. Okay? I know that DF is 12. I know that DG is 17. And I'm after DE, which is this little section right here. How would I find the measure of DE? Yes. Okay, so if I know DG, which is the full length, and I subtract the F away, what does that help me find? FG. So how much would that be? 5. All right, so what I could find directly by subtracting the 12 away was FG. Now how does that help me find DE? They're congruent, exactly. So the direction said that they're congruent, so because I know that this is 5, what's this? 5. So DE is equal to 5. Everybody see how I did that one? Using the idea of congruency. Okay. This next one here is now throwing variables into the mix. All right? Same process. Doesn't matter what information they give you. It could be smiley faces. It could be names. Right? Part plus part equals whole, and whole minus part equals part. Regardless of whether it's numbers or variables or both. So in this picture, I know that this section right here is x plus 3. I know that, oops, sorry, I don't know why I did that. This is 2x minus 6, and I know that the entire thing is 12. I'm looking for the value of x first. How would I find that? Yes.
Add T, E, and E.
Okay, so can I write an equation? How would that equation look?
X plus 3 plus 2x minus 6 equals 12.
Very good. Part plus part equals whole. I know what the two parts are. They gave me expressions for those. And I know the whole was 12. So I can take part plus part equals the whole thing. And I just write an equation. Okay? And how do I solve for x? Use your algebra. You can walk me through that. Yes.
Add the x and the 2x.
Okay.
Get 3x. And then you add the 3 and the negative 6, and that gets you negative 3.
Okay.
And then you would add 3 to the 12.
All right.
And then 3. And then you would divide by 3.
Very good. So what does that give me for x?
5.
5. All right. Do I stop here and move on to the next question? No, you go back to the directions. It says find x and then evaluate. No. Evaluate. No. Evaluate. We talked about this last time.
5.
Evaluate the measure of segment DE and the measure of segment EF. Remember, when it doesn't have the little thing above it, it means measure up segment blah blah blah. Okay. So I want you to evaluate the length of each of those. How would I do that? Plug it in. Exactly. We just got x. We're going to plug it into the expressions that they gave us, and that will give us the measure. So DE is equal to x plus 3, which is really 5 plus 3, or 8. And then what's EF? It's 4. Now when you get these two numbers, how do you know, or how do you check your answer that you did it correctly? Why would 8 and 4 make sense?
Because when you add them together, it's UTF, which is 12.
Good. Yeah, we know that it was supposed to be 12 altogether, and 8 and 4, when you add them together, you get 12. So there's little mental checks you guys can use to make sure you're doing it correctly. All right, is everybody okay on those first 1, 2, 3, 4 examples? Yes.
Let's do the third one again.
Third one. So the one above this?
Yes.
All right. So we knew the full length was 17.
Right.
And we knew that this section right here is 12.
Oh.
So do you know how we found this is 5?
It is 5, right, but if you do 5 plus 12 plus 5.
No, but so this 5 is included within the 12. So this section right here is actually 7.
Okay.
See how this 5 is it's within the 12.
Right.
It's not in addition to, it's already embedded in the 12.
Makes sense.
Good question. Yes.
For the one we just did,
Yes.
is like x equals 5 have to be part of the answer, or would you met the measure of the?
Well, it wants you to find all 3 of those things. So you would circle all 3. Yeah, it's part of the answer. All right, if nobody has questions on those 4, I would like you guys to try the next 2 on your own. Okay? Try this one, make sure you put everything into the picture. This last one here, you're gonna have to draw a picture for yourself before you label it. All right, so give those a shot. I'll walk around if you have questions. I'm gonna put the answers on the board so you guys can check to see if you get the right answer in the end. And the last question, I do require that you draw a picture because that's something I'm going to be testing on the unit test. to be able to draw the picture for me. Alright, does anybody have any questions about these? Yes.
For the second to last one, yeah, I don't get y equals 6.
Okay, did you write an equation?
Yeah,
What's the equation that you wrote?
6y minus 6 minus 3y plus 4 equals 8.
Okay. That is a perfectly valid method of doing it, except this is where you can make a mistake, so watch really carefully. Did you include parentheses?
Oh.
Because when you're subtracting, so if you're subtracting an expression that has two pieces, you're subtracting both of them, so you would need to distribute the minus,
Okay.
which would make this a -4 instead of a positive.
Okay.
You guys can use the subtraction method or the addition method. Could you have also added some stuff together? Sorry. Couldn't you have said that 3y plus 4 plus 8 is equal to 6y minus 6? Yes, you guys could have done the whole minus part equals part, or part plus part equals whole. Whatever method you guys want to, as long as you have all the information, you're good.
For the last one,
Yes.
where'd you get 6s to?
Well, first of all, -6 would not work because you get a negative value. Did you write an equation?
Yep.
What was it?
Well, for SU I got 3 plus 18.
Nope. That's not you. Okay, can you tell me how you drew this? How'd you draw it?
So,
Obviously, you have a segment, right?
and S would be the left flank, and then T would be in the middle.
Okay, specifically, what about the middle? What does that mean?
Oh.
What is a midpoint? I know we haven't specifically talked about it yet, but what is a midpoint?
It's like halfway to center.
It's halfway, right? It's the center of something. So what do I know about these two? They're congruent. That was hidden in there. Okay? Sometimes they'll have that kind of situation where it's hidden in there what you need to do. You need to understand what a midpoint is. That it bisects the segment into two congruent parts. So would I use part plus part equals whole in this situation? No, they didn't even tell you what the whole length was. They didn't even tell you what SU is. So you can't say this plus this equals anything, because you don't know. So what would I do instead? Or,
You would do 2x plus 6 equals x plus 12.
yes. It's just a straight up equation. You say that 1/2 is equal to the other half. And then you solve that way. So sometimes when you guys have congruent, instead of adding stuff and setting equal to the full length, you would just set the two parts equal to each other. And that was hidden in the question with the context of midpoint. Questions on those two? Okay, if you guys don't stop me, I'm just going to move on. All right, so I made a little note here for you guys. Woo-hoo. All right, I made a little note. If you guys see bisect, that means you have two equal parts. And if you guys see midpoint, that also means you have two equal parts. So make sure you're looking for those words in the directions, because that'll give you a hint that you're going to need to have congruent parts in there. Now, the segment addition postulate, which we just saw, with that idea of part plus part equals full for segments, the exact same idea applies for angles. So you could have your full angle here, which would be AOC in this picture. You could have part plus part equals the entire thing the same way. So what's the measure of AOB in this picture? Ready? 28. And what's the measure of BOC? 31. So what would the measure of the full angle be? 59. It's the same idea. If you have the two parts and you want to know the full measure, you add them together. You can still do the, if I knew the whole angle and I only had one part, you can still subtract away to find the other part. It works the exact same way. The pictures just look different because we're working with angles now. So because angles are a little bit, they take up more space to draw, I only have one diagram for 3 questions. All right, so you can write lightly or erase and redraw, whatever you guys want to do. But for this first example, I know that JKL is 20. Now this is why we practiced naming angles last time, because you need to be able to see that name and find it. Can you guys find angle JKL? JKL is right here. It's 20. What else do I know? LKM is 52. I'm after JKM. How would I find angle JKM? Second? You would subtract. I know the full angle is 52. I know part of it is 20. To find that other part I don't know, I would subtract. So 52 minus 20, 32. Does everybody see how I did that? I understand it's more visually complicated with angles, so you're going to need to be patient with yourself. But 52 is the full angle, and I'm looking for just part of it, so I subtract the 20 away. All right, what does this tell me right here? I'm going to erase what I just drew because I don't want that anymore. It resets for each question. What does that word bisect indicate for us in this question? 2 parts are equal. I just got to find out which parts. Okay. So it says that KJ. By the way, what does this symbol mean? It's a ray. So ray, KJ, right there. It bisects this angle. So what does bisect mean? 2 equal parts. What 2 parts are equal, and how do I indicate that they are equal? LKJ and KJM. How do I indicate that they are equal? The little arcs. So I have 2 congruent angles in this picture. I know that LKJ is 32. No. Okay, I know that this is 32. What else do I know? NKM is 55. They want to know the measure of LKN, which is the entire diagram. How am I supposed to do that? I don't have all of them written in.
Since we have a congruent, you can immediately infer that we have other angle, like biceps 32.
Yes. They didn't specifically tell you, they didn't write out JKM is 32, but I can extrapolate that it is because they've been bisected. If I know one half is 32, the other one's 32. So what's the full measure? 119. 55 plus 32 plus 32 equals 119. So again, sometimes you have to jump through hoops. You have to find missing pieces in order to find the final answer. Everybody good with that one? All right, try the next one on your own, please. This one also applies to this picture, so you can erase the information or just add on top of it, or redraw the picture if you prefer. Go ahead and try this one to find the value of x, and then we will reset to move on to the last few on that page. That question you guys should end up with 7.3. Everybody get that, or should I explain? Okay, I need you guys to tell me what equation I would write. Obviously, to draw everything into the picture, it will not be clear for you unless you've labeled the picture, and then it will become clear. Yes. No? If you guys look at the diagram, which I'll erase one. Whoops. Come back. All right, in this diagram, they're telling us that, where are we? What question are we on again? Oh, that one, okay. So I know that the full angle is 150. I know that this angle right here is 82. Oops, pretend that's an 82. And then I know that this right here is 10x minus 5. All right, so how am I supposed to find x? There are a couple different ways you can do this. Yeah.
I subtracted 150 and 82, and then I did 10x minus 5 equals 68.
Okay, so you knew that x was only pertaining to this angle right here, so we need to figure out what that is, right? You said the whole thing is 150, and the part that we don't want is 82. So you can check the 82. Do 115 minus 82. I believe that gives you 68. Yes? Okay, so you know that 68 and 10x minus 5 are talking about the same angle, so shouldn't they be equal? If they're labeling the same picture, they should be equal. So you do 68 equals 10x minus 5, solve that, you should get 7.5. Sorry? 7.3, sorry, 7.3. All right, you could have also done 10x minus 5 plus 82 equals 150. If you wanted to write out the full equation. Either way, it will work. Okay? All right, we're leaving that diagram and moving on to this one right here. Okay, so these next questions are all based on this picture. So first one says that angle BAC is 27. BAC is 27, this guy right here. And then DAC, which is right, oh, this is what I'm trying to find. This right here. Right. What does this mean? It's a right angle. Does that stand for a number? A 90. So see how none of the directions here say that FAD is 90. You need to know that that's given to you in the little box in the corner. So how am I supposed to find angle DAC? Any ideas? Sometimes it's not clear until you put a little bit more information into the picture. Yes, Keely.
180 minus 90 minus 27.
Okay, so a couple things. Where did you get the 180 from? A straight line. You guys see how this is a straight line? So all these angles right here, all of this like span of angles, they all add up to 180 because it's a straight line, right? So that's one part. And then I heard, okay, so we're going to subtract the 90 away. And then I heard 27 times 2. Where'd that come from?
2 27s that
Okay, so remember these little arcs? Remember little arcs? If this is 27, what's this? That's also 27. Like I said, sometimes they won't specifically tell you an angle measure, you have to look at the markings. Okay? So the only angle I don't know is this one, which is what I'm looking for. So you can do 180 minus 90 minus 27 minus 27. That'll give you the angle you're looking for. Okay. What do you get? 36. And just to be safe, you can add them all up again. You can do 27 plus 36 plus 90 plus 27. Make sure you get to your 180. But that's the process you would follow. So there are a couple of things you guys had to look out for. The fact that they all add up to 180, that you had to use all the angles together instead of just like one or two. And then you had to use congruent angles to move the 27 over. There can be a bunch of those little details to pay attention to in these diagrams. All right, if you reset, you can erase that, or you can redraw the picture, whatever you prefer. Okay, well, one maybe not. Okay, hold on 1 second. Why are you doing this? Such a pretty sound, and yet it's still. 1 second. I don't know. Oh, technology, why do you hate me? I'm just trying to erase this so that I can show you the next one, but it doesn't want to do that for me, which is weird. Actually, you know what? Why don't you guys try that on your own? While I'm getting my technology worked out, I want you guys to try this one and this one on your own, see if you can figure them out. Work together if you need to. Okay, fine.
You're trying to find expense. So then you go.
Alright, let's regroup for a second. Regroup for a second. Did everybody get x equals 8 and e equals 37?
Yes.
Okay. Did we find out this one? Does everybody understand why this one is 11? Would anybody care to explain?
Okay, wait. I think I can.
Anybody like to give this one a shot? Irene?
Try. Okay. So
Let me put the information in and then you can explain. Alright, everybody listen up. In case you're confused on this one, Irene, what would we do?
okay, so you know, like the line at the bottom is 180.
Okay?
So you have 180.
Yes.
And then you know that the right angle is 90.
Okay?
And then you know 80.
Alright?
So you subtract, you go like 180 minus 90 minus 80.
Okay, what does that give you?
And that gives you like the little FAG thing.
This
That's
one right here? Right? You know that this is 80, and then this is 90. So can I find this little snippet right here?
yeah.
What would that be? It's 10. Okay?
And then that's congruent to the CAB.
Okay?
And so you just forget about the other stuff. And
Okay?
if to find, like you go 80 minus 10,
Okay?
and that's 70, and then you do 6x plus 4 equals 70, and then you just solve that.
Yep. So you have to use this information to find this angle, to find this one, to figure out what this little piece is, which is 70, and then you can set those equal to each other. Alright, so that was a lot of going around in a circle to figure out where you needed to be. Alright? That's the kind of, guys, that's the kind of manipulation of diagrams you guys are going to be expected to see. Okay? So you need to make sure you're getting used to seeing those kinds of loopholes. Everybody okay with those? Alright, a couple more questions on the next page and we'll be done. Alright, on the test, and I think maybe one question on the quiz, I can't remember because I haven't seen it recently. You guys are expected to take a description and draw a picture. Okay? So I have a picture here, or sorry, a diagram that has B between A and C. So how would I draw that? Okay, well, a segment. What would I call this?
A and C.
Okay? You can, well, it doesn't have to be in the middle. You can put it wherever you want. If it just says between, it can be anywhere. It doesn't have to be specifically in the middle. Then I know that A to C is 10. Well, okay. I know this is 10. I know that AB is, oh no, 20 minus x squared. And I know that BC is 2 minus x. Okay. So what do you guys think? Anybody tell me what an equation would be that we could write? Haley.
20 minus x squared plus 2 minus x equals 10.
Very good. Now, does anybody have a little hint on what we might need to do for this? Factor. Oh, that's why we practice factoring. We practice factoring on the first day because we need to use factoring to solve. If you guys see an x squared and an x in the same equation, factoring is involved. Now, does this look like the setup we need for it to be factored? No, this is real sloppy and messy. We'd have x squared, then a number equals 0. So I need you guys to help me rearrange this a little bit. I need the x squared, then the x, and then the number equals 0. I'm going to maybe move the x squared over here so it's positive. It's helpful that the x squared would be positive. So if I add the x squared, I'm just going to move everything to the right side. So I have x squared over here. I add the x. And then if I already have a 10, and I subtract a 20 and a 2. So basically subtracting 22. 10 minus 22. Like this. I moved everything to the right because you want to try to have x squared be positive if you possibly can. So I moved everything to the right side. There's nothing left on the left side except for 0. Okay, so now this is where we factor. Remember we practiced this? Alright, I need two numbers. I need to multiply the first and last number together, which is negative 12. What's the middle number? 1. So I need two numbers that multiply to get negative 12, but add to get positive 1. Think about it. Not negative 4. 4 and negative 3. Make sure your signs are correct. Be very careful. Can I go straight to parentheses? With this example, remember there are two different types where you can and can't. Can I go to parentheses? Yes, you can. If there's nothing in front of the x squared, that's why I wanted it to be positive. If there's nothing in front of this, you can go straight to parentheses. So I have x plus 4 and x minus 3. Now, remember, I wanted to know what x is, so this is where you have to solve. We talked about this. What's the one extra thing you do to solve? Yeah, you set them equal to 0, which basically does what to those numbers?
Just makes them opposite.
Yeah, they basically change signs. So you set each of these little equations equal to 0. You can write them separate if you'd like. But if you solve this, you get that x is equal to negative 4 and positive 3. Okay? Now be very careful. One of these numbers may or may not work. Let's take negative 4. If you plug in negative 4, that'd be 2 minus the negative, which is 2 plus 4, right? That gives you 6. If I plug in 3, what's 2 minus 3? Can a segment be negative 1, whatever long? Can something have a measure of negative value? No. So this would actually, that would not be a valid answer. Okay? I want you guys to write a little note for yourselves. Check. 4. Oops. Let me write these. Now, I want you to write this. Check for negative values. Write that down for me. When you guys solve by factoring, almost always only one of the numbers is correct. Sometimes it's both, but that's very rare. Most of the time, one of the numbers is going to give you a negative result, and you don't want that. So you have to factor and get two answers at first, but then you have to check both of them. And if one of those numbers gives you a negative value for the length of the segment, you got to get rid of that. Not a valid answer. Right? Notice how it says valid, not find all. It says find all valid. Right? So check the ones that give you negative values. You don't want those. Say again? The negative 4 is fine. The x being negative is okay. It's just when you plug it in, you don't want the value of the segment to be negative. These numbers to be negative, you don't want the value up here to be negative when you plug it in. Okay. Let's try another one. This one also involves factoring. Let's reset and try another one. Given, we're drawing another picture, guys. Given that t is between a and l. A, l, and then t is right here. I'm trying to find all valid values of AT and TL, or the measure of AT and the measure of TL. I know that AT is x squared plus 2x minus 2. and I know that TL is x minus 2, and then the whole thing is 24. Draw the picture for me. Make sure that you have that drawn into your notes. What equation would I write? Let's start with an equation and we'll go from there. What equation can I write? Yes.
X squared plus 2x minus 2 plus x minus 2 equals 24.
Very good. This is that same idea that we were working with on the first page. Part plus part equals whole. It just looks a little more complicated, but it's the same exact idea. The two parts added together equals the full length. Now, what's your signal that you're going to use factoring here? There's an x squared and an x. If you have x squared and x together, you know you're going to be factoring. So let's neaten this up a little. So the x squared is by itself. Are there multiple x's here?
Yeah.
Okay, can I combine them? All right, what would I get? Okay. What? Disappearing ink. Yay. X squared plus 3x, then what? I have a negative 2, a negative 2, and then a 24 on the other side. I want them all together. Negative 28. Alright, make sure you have 0 on one side, everything on the other side. Alright, here we go for factoring. Multiply the first and last coefficients together. So that would be 1 times negative 28. Gives you this number up here. What's the middle number? Middle coefficient is 3. What two numbers multiply to get negative 28, but add to get positive 3?
7 and negative 4.
7 and negative 4. Can I go straight to parentheses? Yes, I can, because there's nothing in front of the x squared. So I'm going to have what inside? Anybody? X plus 7, x minus 4. They maintain the sign that you had when you were finding numbers in the first place. Now I don't want to just factor, I need to solve now. So what would I get from my x values? Negative 7 and positive 4. Oops. Alright, those are the x values. Were they asking for x? No, they were asking for the valid measures of AT and TL. So if I plug in negative 7, use your calculator, do some mental math. If I plug in negative 7, would I get valid numbers? No. Specifically this one, I can see negative 7 minus 2 would be negative 9. Can something be negative 9 centimeters long? No. Okay, so this negative 7's out. Can't use that. Ooh. Come back here. Oh my goodness. You stop. Alright. Inside of there is also 4, right? I don't know why it's doing this. Let's check 4, right? I know those other ones aren't going to work, so I'm just going to scribble them out. Alright, if you plug in 4, what do you get? 16 plus 8. Is it 24? Yeah, I think my mental math is wrong. Yeah, that's definitely 22. Okay, so AT. Is everybody with me with AT being 22? All right, what would TL be? 2. Is everybody with me? You gotta stop me if you're not with me so I can explain it. Otherwise, I'm gonna keep going. So everyone understand what we're doing when we're testing the numbers? Make sure that they're not negative within the diagram. Okay. What about this next one? It doesn't involve factoring, don't worry. But I do need you guys to draw the picture correctly. It says Q is a point in the interior of angle POR. How would I draw that? Okay. I'm going to have an angle like this, like Brody is describing. Now how can I label this one just to start? Where does the P, the O, and the R go? Okay, specifically with the O in the middle, doesn't matter which side the P and the R are on, but you need the O in the middle. And then how would I do the Q as a point on the interior of? Just stick a Q somewhere and draw a ray. Alright. We have a bunch of measures here that we're going to put into the diagram. So POQ is 3x plus 7. QOR is 5x minus 2. And then the entire thing is 61 degrees. I want to find the measure of POR. No, I don't, because I already found that. I want to find x, the measure of POQ, and I think I meant to say QOR. So you already know what POR is. You get it. Alright, so how do I proceed? Yes.
3x plus 7 plus 5x minus 2 equals 61.
Very good. This is another part plus part equals whole. So I take both of the smaller angles. When you put them together, they equal the full angle. So I take both of the expressions of the small angles, add them together, it equals the full angle. How do I proceed from here? Use your algebra. Can anybody condense that a little bit for me? Yep.
8x plus 5.
Good. And then you subtract. What is that, 56? And then 7. So x is 7. Did everybody get 7? Okay. How do I keep going? How do I find POQ? Plug it in. Plug 7 into this one right here. 3 times 7 is 21. 21 plus 7 is?
28.
Okay. So POQ. Well, 28. What about the measure of QOR? Which one? 33? Yep. Did everybody get all those? Yes? Alright, you guys try the last one on your own, please. Try the last one. Draw a picture, solve the problem.
Okay, wait, so find the measure of ABC.
Alright, does anybody have any questions on this one? Let me know if you have questions.
Wait, you solved it. You solved it. Okay, guys,
Wait, are we finding ABD or ABC?
Oh yeah, finding ABC.
oh, you solved it.
So, wait,
If you're gonna do -3, you just
okay.
for 7, if I do, actually,
I got 2.
What'd you get for that? No.
yeah, so 7 works for this, but if you're grabbing 7 in here, -3 down. Negative, so that's how you know that 7 is not valid. You can't have, when you plug it in, if what you get comes out as negative, whatever you plug it in.
Okay, I was confused with that, like, why? I just forgot to put front.
That's why I didn't work. Okay. It's just -3, that's it.
No, you kind of measure ABC.
Alright, now are there any questions? When you guys factor, you should get +7 and -3 as your solutions. When you plug in 7, it'll work technically for the ABC. 7 will work, but if you plug it in for the other angle, you get a negative, so you can't use 7, even though it worked for one angle. If it doesn't work for the other, you can't use it. So when you plug in -3, you get 18. That's your only valid answer. Okay? Alright, so your guys' homework would be the next page. We don't have time to start it today, but I expect you guys to have it ready for next time.